Alright, my name is deferent, and I'm going to talk about real-world subwoofer setups, implementing them for live shows, different designs that are involved, some basic background behind the various designs, and for those of you who don't know who I am, I've been mixing Red Hot Chili Peppers for 20 years. I mix Soundgarden, Blink-182, the three bands I've most recently been working for. I've designed quite a few sound systems, subwoofer systems over the years, and started a sound company about 30 years ago called Rat Sound that rents equipment internationally for large-scale events. I'm in the fortunate position to where I not only see these speaker designs from a design angle and have designed, built, constructed, and rented them out, but also I get to mix on these configurations, listen to them, and see how they perform in real-world environments. And I get a chance to mix on multiple systems all over the world. As I travel with various bands, I get to see the different setups and configurations that people are using, and I have preferences and issues with different configurations. In order to talk about subs, there's three different parameters that should be looked at. Coverage, which is, is it an omnidirectional sub like a double 18 is? A horn-loaded sub is fairly directional right off the bat. What's its vertical coverage? Not only the horizontal coverage, but the vertical coverage of the individual enclosure or the sub-array, multiple enclosures that are involved. Feasibility. If you have a sub that sounds great and covers well, but it's too big to fit in the door of the venue, or if your sub setup is extremely effective, but it blocks the sight lines, or it pushes the barricade so far from the band that the audience is disconnected, or you get a bunch of bleed onto stage. There's various issues feasibility issues with the setups. And then finally, sound quality. What does the sub setup sound like? And there's a lot of prediction patterns which will tell you what the sub will do coverage-wise. They don't really indicate what the sub setup would sound like. And some of these sub setups that are being used today sound a lot better than others, and there's some significant issues with some of the setups. So, being a fairly complex concept, my daughter Sammy and I made some Lego subs. We actually made a little Lego sub array here. Look at that. That we'll use later on. Little hinges and stuff. So I'm going to cover the various basic types of single box subs. The most common currently is a double 18, double 21, double 15, or just the direct rating. You see the speakers right in the front. For the most part, at low frequencies, these enclosures have close to a omnidirectional pattern, which means they cover all the way around, about the same volume. Maybe they're a little quieter behind, but for the most part, there's omnidirectional. It's important to realize that this pattern is not only limited to the horizontal plane, but it also involves the vertical plane. So wherever you are, the same distance from this speaker, about a piece of string, it should be approximately the same volume. Horn-loaded subs, if you have a sub that's got a speaker in the back of a bunch of speakers there, they tend to naturally be directional. Both in the vertical and horizontal plane. I'm not going to get into those very much because they're not as common anymore, and not as useful for setting up these arrays that depend on interaction between the subs in order to achieve the coverage patterns. Another type of standalone sub would be a directional sub or a cardioid sub, and there's basically 4 different methods of achieving pattern control other than the horn-loaded out of a subwoofer enclosure. Probably the simplest one is to have some speakers. Let's say you have 2 speakers pointed forward and also have 2 speakers pointed backwards in the enclosure. The sound from the back speakers would be radiated first. The front speakers would be on a time delay, And the measurement, they would do some measurements in the design of the speaker, so they'd measure the time it takes for the sound to come out of the back of the speaker, come around the box, and past the front speakers, and right when it's reaching that point, the front speakers would then radiate sound, and it would be an additive summation in the forward axis. And since the front speakers are radiating later, and there's a distance they'd have to wrap around, the sound coming out of the front speakers wrapping around would not be in time with the speakers in the rear, causing a subtractive or cancellation behind. And that'll give you some cancellation behind and addition in the front. Another method of doing this would be to take the rear speaker and reverse polarity on it. Have the sound, in this one, the time delays are reversed. You would have the sound radiated out of the front speakers first, and the sound that wraps around the back as it comes to the rear speaker would radiate sound. But since it's out of polarity, it would cancel out the sound that wrapped around from the front and reduce the volume behind. Now this is more effective at canceling sound behind, but the downside of that is sound from the rear speaker also wraps around front and causes interference with the front speakers, reducing volume and causing some less than desirable sonic issues in the forward radiating area. So they tend to be less efficient. You're wasting some power there, you lose a little volume, you lose a little sound quality, but you gain improved rejection behind the box. That design there has two other similar offshoots. Both of the first two require two separate amplifier channels and a delay on one of those amplifier channels and possibly some processing in order to achieve its coverage. There are some passive versions of cardioid subs where they've taken the sound of the rear and created some chambering, or the way the enclosure is built basically acts the mechanical time delay, and maybe there's a port in the back that radiates some sound, so the sound from the front is canceled out by the sound radiated at the rear port. And a very similar design to that would be to have the rear panel of the speaker cabinet be non-rigid, have some vibration to it. It flexes, either routing a channel in there and putting some silicone. The weight of that, the size of that, and how well attached that is would determine the volume and frequency at which that resonates. That can be tuned to cause a cancellation behind the box of some of the energy from inside the box would come around and cancel out and cause a cardioid pattern. Again, a single amp channel, no processor required solution to creating a single enclosure cardioid sub. For the most part, I'm going to lump all those together into a single entity and just call them a single box cardioid sub for the course of this. I try and stay away from the ones that have the out of polarity rear facing speakers because they become less efficient. There's a sound quality hit right off the bat, and for these multi-box setups that I'm going to show later, we can establish fairly effective cancellation behind without sacrificing the sound quality and having that out of phase component. And also, when you have an out of polarity speaker mounted in the rear, it really needs some open space. So if you have some barriers or some blockage behind it, it can really screw things up. So they're a bit temperamental and unwieldy, so we'll stay away from those for this. Here's some more of the Lego adventure we got into. This is actually Harry Potter on vocals, and we have a stormtrooper from Star Wars playing, I believe that's a guitar or a bass. Looks kind of like a key to me. I'm not sure who this guy is. He looks like another, maybe it's another guy from Harry Potter. Let's look at kind of like how the evolution, or kind of how these subsystems kind of come about. Here in the most basic setup, you've got, you got your band playing on stage, and you put a subwoofer on each side of the stage. Makes sense, looks good, but there's some issues that arise here. If you want to picture it in your mind, a simple way to look at subwoofer coverage patterns is wherever you are equidistant from the sources, they will tend to be the loudest, if there's no other outside effects like time delays or weird anomalies in the venue or building that you're in. So here we're going to get what we call power alley. We are equidistant from the two sub-sources. Just off to the sides of power alley, you are still very close to the center. The subs are very close to the same volume, but you're closer to one set than the other, and you start to get cancellations. I'll call those power valleys. These are areas where we get maximum cancellation just to either side of power valley. This is going to be most apparent in outdoor venues. Indoors we get reflections, which will help dilute that to some degree. And then as we go off, there'll be other areas where we get cancellations, second and third. But for the most part, just that first major cancellation is our primary issue. Off to the sides, as we increase the size of the subwoofer setups, we increase or exacerbate that problem. The power alley becomes stronger, and we get considerable narrowing in the horizontal domain. It's important not to forget the vertical aspect as well. This power alley, if we're looking at equidistant, we're equidistant from these subs here, but we're also equidistant from them here, and we're also equidistant from them here. So this power valley is actually not just an alley. It's a complete disc, or a half of a disc, that goes right down the middle of the stage and up into the ceiling as well. And this is having both of those are significantly undesirable aspects. That can be reduced by using cardioid subs. Now if we use cardioid subs, we have reduced our coverage. We have less behind. So this power alley behind is reduced in volume. The amount of energy radiated towards the ceiling is reduced. But we still have the two null modes, the two power valleys, and a significant reduction in coverage to the sides. To help solve that, a common thing to try was to start pointing these subs outward. Because we have an equidistant point here, we get a little peak right in front. And instead of having that peak here, we can move that peak outward. We can move this peak outward. And now we've slightly increased our horizontal coverage. But it's still off to the side going to be less than optimum, especially with the larger scale setups. Other methods of doing this is to set up an L. Now your equidistant point for this subarray is at 45 degrees. So it's a simple way of increasing your coverage slightly without getting too complex. And even though this is pointed here, you've got a little bit of power. So now you've widened it again, but still you're not going to get significant coverage 90 degrees off axis at this area. It's always important to look at our equidistant points and check out our vertical. In this setup, we've begun to form an arc. So our maximum equidistant point from all subs is probably right in here somewhere. That means we've got significant energy headed towards the ceiling, less than desirable. Alright, that's probably enough for this one. In the next upcoming videos, I'll cover some more complex setups. We'll talk about flown subs, achieving cardioid with multiple enclosures, and some of the concerns with setting up a straight line of subs and creating a delayed arc. And I'll get that done soon. All right.